Hello and welcome to my living room where we are going to do the second experiment in the set of mandatory experiments. This one is the pendulum experiment. I thought we'd do a tour of the house, doing all the rooms in their order of importance. First we're in the kitchen, now we're in the living room. No, you're not going to the bedroom, don't worry about it. So, the pendulum experiment. What do we need to do the pendulum experiment? Well, the first thing we need is a heavy object that will act as the pendulum bob. A simple pendulum is a string with a heavy object on the end, whereas a complex pendulum is one with the same weight all the way down. Luckily, we don't have to consider those in physics. Simple pendulum, much easier. This candlestick has just come out of the cupboard where it was in hiding in case my wife, gets sick of me after isolation. I've removed some of the obvious weapons, candlestick being one of them. The knives are very blunt at the moment as well. Cooking's interesting. You also need a piece of string. This piece of string, in fact, and in order to suspend it correctly so that it always comes from the same point, i.e. no matter where it rotates, it's always suspended evenly, you need a split cork. This is a cork from a bottle of wine. Ask your parents, they'll have lots of these by now. You put the piece of string between the two parts of the cork and you squeeze. And if you notice, then it only oscillates from one point. So your length remains constant through the oscillation. Very important. So split cork for 1 point of oscillation. Of course, you also need a measuring tape and a stopwatch, which is obviously your phone. So you measure from the point of suspension to the center of gravity of the pendulum bob, and that gives you your L, one of the factors you're recording in this experiment. The other thing you need is your time for oscillation. Well, you're going to take 30 oscillations, or 20 or 10, depending on how long it takes. And hopefully you're going to end up with a good result by dividing by the number of oscillations to give you time for one oscillation and then squaring it and drawing the graph, which we're going to do a little editing for that, so it should be fun. Okay, so sir, here we are. We've got all our bits. Where's the pendulum? Well, you're the pendulum. The iPad is suspended from a piece of rope. That's why it was at the funny angle. So you're actually going to see this from a rather unusual position, this experiment. I'm going to adjust it so that the pendulum actually rotates. Now, the first thing you have to know is that you must have a very small angle at the top. You can't set the pendulum over here and let it go and have it in a full sweep, because then it isn't simple harmonic motion. It has to be a very small angle. Less than 5 degrees typically is what would do it really well. So the longer pendulums will keep going for that length of time, but a shorter pendulum, such as the one I've suspended here over my tortoise cage, I'll show you the tortoise. And as you can see, that's why we're at this kind of jaunty angle. I'll have a go at it in a moment to try and get it. But 5 degrees, and you start by counting from 0. And every time you pass 0 in the same direction, you write down, you count the number. Now I'm only going to count to 10 as an illustration and to show you how it works. So here we go. You ready? Go. And 0, 1, 2, 3, 4, 5, 6, and keep going. 7, almost. 8, 9, 10. There you are. So that gives us our 10. I've taken the time, and I'm going to just go on to the next part of the edit. Now, once I have taken my readings for 30 oscillations in this case, which took 20 seconds when I did it in my kitchen just before I started the video, I measured the length, as you can see, from the split cork to the center of the pendulum bob. That's very important. That's there on the left. I then extend to do 6 readings in all to reduce the experimental error, to reduce the percentage error in the experiment. Simply then, all I have to do is divide by 30 to get the time for one period, and then to square that to get L against T squared, because that is the relationship which will give us our straight line graph. A straight line through the origin. As you can see, I plotted our point and I plotted all the other points, and I've also taken this point here as the point on the graph. Now, it's not one of the points from the table. This is a point actually on the graph, and I'm going to take the slope from this. Because our other point is 0, 0, the slope is simply the y component over the x component. As simple as that, and that gives us the slope of the graph. And what we do with the slope of the graph, I'm going to deal with in the theoretical section of the course. But that's how you do the experiment, that's how you find the slope, and I'm hoping that will help.